Okay, so welcome back to the new episode of the Crosse Thinkers Podcast. And today we have Dr. Bart Vanvoorhis, Associate Professor of Psychology, and we will be talking about consciousness, which is one of my favorite topics. Thanks for joining us.
One of my favorite topics, too.
Great. Okay, so let's start with the easy question.
The easy,
What
okay.
is consciousness?
That's the million-dollar question. The reason it's the million-dollar question is, and what makes research in consciousness so difficult, is that there isn't even an agreed-upon definition across researchers about what consciousness is. Somebody like Daniel Dennett might say, it isn't anything because there is no such thing. We only think there is. Two of my heroes in the study of consciousness, one is philosopher David Chalmers. He's current. And then a guy considered to be the father of American psychology, William James, and they both have great insights onto sort of what is consciousness. And David Chalmers says, there's nothing we know more intimately than our own consciousness, but there's nothing that's more difficult to explain. And William James says, and that there's a lot of this in psychology, we all know what it is until we're asked to define it. You know, and I bring this up when I'm teaching my students in psychology, is that most of our definitions, most of our concepts that we're interested in are very much like that. So I can ask them, how many of you have been anxious? And they all raise their hand. It's like, well, if you know you've been anxious, you must know what anxiety is. So define anxiety, and then they're blank. It's like, well, I mean, I know what it is, but I don't know how to define it. So I fall back on sort of the first easy definition is just to say, you know, subjectivity or self-awareness, first-person experience. And my favorite came from a famous article by Thomas Nagel, who wrote, "What is it like to be a bat?" And he says in that article, if there is any consciousness at all in whatever, that thing, that animal, then to that extent there must be something that it is like to be that thing, that animal, that whatever, for the thing, for the animal. So I like to think about a rock, for example. So I can easily, to me, not everybody would agree with this, but to me, I imagine that there's absolutely nothing that is like for a rock to be a rock. No, there's, you know, something along the lines of, it took me 120 million years to be washed up onto the beach from the ocean, and some oof comes along and picks the rock up and tosses it, and the rock's like, no, you know, I just got here and you're throwing me back. And so I don't, you know, rock angst about not having legs or not being mobile. I don't think there's anything. So to me, I can easily imagine that there's nothing that it's like for a rock to be a rock. But then, as soon as I get into, is there anything for a mosquito that it's like to be a mosquito? And so
probably it's safe with plants.
Right,
Okay,
exactly.
so plants you can still say it's like rock.
Yes.
Right? But now we push the mosquito.
And there's currently quite a lot of research and debate on the extent of plant consciousness, in part because they have such a complex and unique communication system. So if one plant feels a threat, it releases chemicals through the root system, which is detected by other plants, and then they can start a defense against that threat. So, you know, I don't know that I certainly wouldn't grant anything close to human consciousness to a plant. I don't think they sit and ponder. But when I get to a bird, then I really start to think that, yeah, there's probably something for that bird that it's like to be a bird. I don't know what bird consciousness would be like. I don't know how much birds sit and ponder. I think they probably plan. But I often watch a bird flying against the wind, and I wonder, is there anything in that bird consciousness that's like, man, this really is difficult, or this really stinks. I hate the wind. I hate trying to fly against the wind. But there was a group of 200 or so consciousness researchers about 4 years ago, I think, signed a declaration claiming that all mammals and many birds were conscious.
What is the research based on? It's easy to say something has feelings.
Yeah.
If you start to anthropomorphize them.
Yeah.
But can you test it? Can you test it by electrons, whatever? Just say, hey, the birds really have this, have
right.
the reaction, because you cannot interview the bird.
You can't. No, and even self-report when we're talking about a organism that we can communicate directly with, we don't know what its consciousness really is. Mm-hmm. What we get is a report of what their consciousness is like. So that goes kind of to the heart of Thomas Nagel's point, is that I can be certain of my own consciousness, but I have no idea about yours. For all I know, you're a zombie who talks and speaks and behaves just like a conscious human being, but it's all dark inside. So I have no way of knowing whether you're actually a conscious human being. And in the debate of the question of, well, then what does consciousness do? Does consciousness do anything? And there's two camps to that say, no, it's like consciousness in essentialism. We would act and talk and behave exactly like we do whether we had consciousness or not. So that sort of zombie world, I really don't know if anybody else is conscious.
So that's almost like you assess consciousness not by subjective experiences but by behaviors.
Yeah.
Input and output,
we do.
How they behave.
Yeah. And there's a classic test, it's called the Turing test, that was a sort of thought experiment designed. People have actually carried this out. You have a machine behind a partition, and the person communicates, whether it's tapping on the keyboard or whatever, with that machine. And if they can't tell whether they are interacting with a machine or a person, then the machine is sort of past the Turing test, and we would have to claim that machine must be conscious.
So that's purely behavior.
Yeah. Yeah. But, it gets really muddy if we think of consciousness as not being restricted to humans. And it, that because we define it as subjectivity is what makes it even the more difficult to study. And a lot of people take a brain approach to studying consciousness, but it oftentimes steers us into thinking about consciousness in the wrong way. That what brain state indicates consciousness? We look for neural correlates of consciousness. It's like, well, to even do that, you have to have a state of not being conscious. And it's like
the control group.
Yeah. If we're ever awake, then that's coupled by consciousness. Most of our sleep is coupled by consciousness. So it's not as if I can put somebody in an unconscious state, perhaps, and see what is different in their brain, So to find where is consciousness in the brain is a exceedingly difficult question to address.
Is that even possible? How do we identify like a person is alive, but meanwhile no consciousness?
Yeah, it's
Is it almost impossible?
almost impossible. Even relatively recently, 15 years or so now, people that we have thought to be in vegetative states, because they're really unresponsive to just about anything, but when we measure brain activity, we can ask questions like, imagine grabbing a cup. And when we do that, even though there's no observable overt response, if we're measuring brain activity, we can see the brain light up in the area, premotor cortex of like motor movement planning area, and we can see there's activity corresponding to imagining grabbing a cup.
So they did receive the question.
Yeah.
They did think about it. They
Yeah.
did make the request, sending the
Right.
signal, say, I want to move this. It's
Yeah.
just I cannot actually move.
Right.
Wow, that's interesting.
Yeah, so that, and then of course you can imagine the ethics of, pulling the plug on people in vegetative states, and I think that will lead to a very subtle test that might give family an indication of, is there any hope? Is there a conscious individual in that presumably vegetative state person? And sometimes I think we could get evidence that there might be. Even perhaps we could pose questions in a, if you would prefer to have the plug pulled, imagine raising your left hand. If you would prefer to stay the way you are, even though recovery is unlikely, imagine raising your right hand, because if we did that, we might be able to see differential brain activity in either the right or the left hemisphere.
Mm-hmm.
I don't know if it will ever get to where we would be able to address questions like that, but
Do we have any people who were originally in vegetable states, but then they end up recovering?
yeah, there have been.
And then did they actually say, like, when I was there lying down, I couldn't
Oh,
move?
there
I
are
feel things?
there are some cases of that. I think one was written up in a book called Ghost Boy.
Mm-hmm.
Fascinating story of a guy who had gone into, and I don't remember the backstory on it, but he had had like an illness, a severe virus or something, and high temperature, and then never came out of it. Was presumed in a relatively vegetative state. I mean, he was institutionalized for a long time and had people constantly caring for him, but nobody thought, because he was unresponsive, generally that there was anything going on inside. But he had a fully conscious life going on inside and was fully well aware of the abuse he was getting and the institutions he was in, and eventually he got to the point where, with advances in technology especially, he was able to communicate through the use of computers, and fascinating.
Cool. So, here's my follow-up question. So we have consciousness, and seems like it's a special gift we get from evolution, the evolution process. But is it just a happy coincidence, or actually, in order to survive, and the ultimate evolution direction should be, everybody should get consciousness. It's just like we are there yet. We are there first.
Well, this is going to be true for almost all of my answers. I'll qualify this before we go any farther. This is sort of my take or my opinion, but however many people study consciousness, there might be that many different answers if you were interviewing somebody else. So I think that that consciousness didn't evolve per se. I think it was a byproduct of the evolution of the ability to communicate and the evolution of language in our case, but for other animals we'll just say communicate. So there's an analogy that's often used about polar bears. They're huge, right? they require a massive caloric intake every single day just to survive. Well, they live in the frozen environment. It would seem counterintuitive, a mistake of evolution, that they would evolve to been such huge animals. But hugeness didn't evolve per se. What they needed was a very heavy coat and a lot of fat to be able to survive the cold environment. Well, to accommodate the insulating fat layer and a very heavy coat, they had to be large. So it was the coat and the fat that evolved, not a direct evolution of a large size for polar bears. So I think, this is again my personal opinion, I can imagine back or think back to, our ancestors, Neanderthals, communicating largely with different tones of grunt before any language directly had evolved at all. But we're in the forest, and suddenly I realize I can make different sounds. I can make a low tone grunt or a high tone grunt, for example, and when I see this particular shape of tree, I and when I see a different type of tree, maybe a taller, skinny one, I say a higher pitched one. And if I just repeat that enough, whoever I'm with is going to realize that I'm using a sound to depict a difference between two different kinds of trees. Then we're sitting around, if we've invented fire yet, the campfire that night, and now I can make the grunt and refer to a tree that isn't there with us at that point. That's a huge step in communication, to have a reference, a symbolic reference to an object that I can make a grunt, and in your head now you have an image of the tree that I made that same grunt to when we were actually standing by the tree. So now I've evolved the ability to communicate with you about things that aren't even right here in the right now. And as soon as I develop that ability to communicate outside of myself with you, being almost instantaneously, I'm probably going to have the ability to communicate inside my own head with myself. So that sort of external communication probably very quickly led to internal communication. And I think consciousness came along as a byproduct of the evolution of advances in communication. I think language of communication is one of the critical elements probably of consciousness. A lot of things are. Attention is a critical element of consciousness. Awareness is a critical element of consciousness. All of those sort of play a role, but none of them are consciousness in and of themselves.
So is it fair for me to say like associate memory is involved, and also expression of consciousness is almost like expressing your feelings, which is communicating with others, almost actually appeared in your theory simultaneously with feeling things inside, because you talk about like communicating with others, and then I actually start to find self. Yeah. Before that, I don't even have a concept of self, because I'm going there doing things. Chemical reactions.
We're probably up until that point largely stimulus response animals, where there's not a lot going on inside, and even in the evolution of the brain, and I use this to you can look at the brains of humans and then other animals. We have different areas. We have a association cortex. That's sort of what's happening in between input and output, the planning, the thinking, the pondering. We have motor output areas of the brain. We have sensory input areas of the brain. Well, humans, relative to most other animals, have a lot of association cortex. You look at a rat, and almost 100% of the brain is input and output. It's motor output part of the brain, it's sensory input part of the brain. So they are largely, I think, compared to us, stimulus response animals, and we are probably much more stimulus response animals at one point in time. From an evolution perspective, the oldest part of our brain is the brain stem, where we didn't have any advanced cortex at all, really, so to speak. But the earliest part of the wrinkly part of the brain, the cortex to evolve, is the part that allows us to synchronize events, stimulus input, into a single event, and then remember all of that as having occurred together. So if you think about any experience you have, say you go to a club to hear a band, there's sights and sounds and lights going off and people dancing and the smell of alcohol and people's cologne and people's perfume, and there's emotions that go along with that. The happiness and excitement and hearing a band, and everybody's, it's a lively environment, and maybe you're attracted to somebody there, and all of those elements, the sights, the sounds, the smells, and the emotional experience behind it, are all processed by different areas of the brain, but they all have input into a common area of the brain called the hippocampus. And we know now that when you, the next day, the next week, the next year, sit back and reminisce to yourself about that, even, oh, that was a blast that night, we went to that pub and watched that band, and I met my girlfriend. When you're remembering that, all of those areas that were originally active while you had the experience get reactivated, and they're all synced together, perhaps through another area of the brain that has our primary biological clock, which ticks on, sort of a perfect 24-hour rhythm. And that hippocampus that allows all of those to be linked as having occurred together, and then it projects back out to the rest of the brain to activate those areas when we are recalling an event. That is one of the first areas of the cortex to evolve, and memory in that way plays a huge role. It's another one of the elements of consciousness. None of these can we say are conscious. So they're necessary but not sufficient, or sufficient, whatever it would
necessary,
be.
yeah.
But you can't have, you can lose your memory, you're still conscious. Mm-hmm. We know people who have lost most of their ability to have any new long-term memory stored whatsoever. Even some that have lost that ability, plus they lose their ability to recall anything from the past. So they are literally trapped in 20-second blinkers of time. Every 20-second slice is a brand new event, not attached to anything in the past, and they can't project anything into the future. But they could sit and have a brief conversation with you. You certainly wouldn't claim them not to be conscious. So memory isn't, you cannot have memory and still be conscious. You cannot be paying attention, you're still conscious. I cannot be aware of something in my environment, but I'm certainly still conscious. So awareness isn't consciousness, attention isn't consciousness, memory isn't consciousness, language isn't consciousness or communication. Emotion isn't in and of itself conscious either. There are people who have a lot of our emotional experience comes from bodily sensations. Changes in heart rate, changes in chemicals in the blood, hormones, and we assess that, we interpret that, and that gives us a bead on, a lot of interpretation of what is this am I experiencing, because the chemical and the physiological response to most emotions is almost identical. So As a matter of fact, there did a research. They had one group of subjects watching a horror flick, a scary movie, and the other group were watching pornography. And observers could not tell you which group was watching what. So even from the outside, the emotional expression looked very similar. So my heart rate might increase because I'm attracted to somebody, or it might increase because I'm at an uncomfortable height, or I'm on a swinging bridge, or I'm going to have to come give an interview on consciousness. But the physiological and physical chemical response of that anxiety is very similar. So oftentimes we look to our environment to say, what emotion am I experiencing? Well, there are individuals who have spinal injuries, and depending on where it is in the spinal column, if it's high enough up, they don't get a lot of that input that we typically get from our body that produces a lot of our emotional experiences. And they sometimes will feel devoid of a lot of that emotional experience, but certainly they're still conscious.
Definitely still consciousness.
But again, a very important element. I mean, and probably consciousness is a much more whole body thing than most people look at. There aren't very Antonio Damasio is one of the few who emotions play a huge role in his view of consciousness, but that's not the norm, and it's probably, probably one of the barriers that keeps us from knowing more about consciousness is, and this is true across much of science, but each person doing their own little work is looking through a very small lens. And when you look through that small lens, you ignore so much outside of that lens that you're not probably getting the whole picture. We look at almost exclusively neurons in the brain in an attempt to understand consciousness from a brain perspective, but nobody has looked at glial cells, which have equal volume in the brain. They actually outnumber neurons by about 10 to 1. They play a huge role in determining neurofunctioning, sort of monitoring. Glial cells will know when a neuron's firing. It can release chemicals that will neutralize the neurotransmitter released by the neuron. So for all we know, the neurons are being controlled by the glial cells, and we don't even, nobody's looked at glial cell potential role in consciousness at all.
So eventually maybe even brain is not the boss.
Yeah, right.
Interesting. Yeah, that actually ties back to my next question is like, okay, we have consciousness. Like, what are the ways we can study consciousness? Like, I clearly hear from you, like, you can study the brain cells, approaching it from a biological neuroscience perspective. Maybe there are something from physics. I heard about theories about computational, and also I hear theories about quantums.
Yes,
that's right, or probabilities, and also it can be from psychological, behavioral, or even like very subjectively from philosophical. So, what are some popular approaches to study consciousness?
Well, I would say the most popular right now are typically brain approaches.
That's neuroscience, right?
Yeah.
Neuroscience.
Yeah.
Okay.
And a lot of them are pairing up with philosophers or physicists or mathematicians. It's a very broad field. A lot of people from a lot of disparate areas interested in this. But even psychology now, since the 90s, has really had a focus on the brain. We've switched over from teaching what was called cognitive psychology, now almost doesn't exist. It's cognitive neuroscience, so everything is tied into the brain. One of them I find really interesting. I have just a personal attraction or interest in the quantum mechanics and quantum explanations. And I had mentioned that earlier about it being very difficult to have a brain in, a conscious state, and I can compare it to a brain in a not conscious state so I can see what's the difference. Well, one way you can approach that is from somebody under anesthesia. So there is an anesthesiologist from Arizona State, Stuart Hammeroff, who became intensely interested in consciousness as an anesthesiologist. And he's worked with Roger Penrose to develop a quantum theory of consciousness, and they place it in the microtubules of proteins and the microtubules of axons. It's hyper complex, and I'm not going to get into any of the details here, but there's some quantum superposition of proteins in the neurons and the dendrites of the neurons that he calls it the Bing moment of consciousness. So when that quantum event happens in the microtubules of the axons and in the superposition of proteins in the dendrites, then that's sort of the brain correlate of consciousness. So, we have Roger Penrose there. Some of the greatest minds in the world have spent time attempting to solve the problem of consciousness. Francis Crick, this is very simplistic, but in essence, we have this problem of life. What's life? What's the secret of life? What's the difference between
DNA,
alive and dead? And the double helix structure of DNA, and he kind of sits back and says, well, now what? And he decided, well, that the greatest remaining mystery of the universe is consciousness, and so he spent the rest of his life, not just his career, but the rest of his life, attempting to explain consciousness. His is a brain approach as well, again, neural correlates of consciousness, and to him, what he wanted to solve is what he called the binding problem. It goes back to what I mentioned earlier about any experience we have is processed in disparate areas of the brain. Well, just imagine you're standing on the street corner out here waiting to cross the street, and a big blue bus drives by. And you think about all of the elements of a perception of a blue bus driving by. You're going to smell diesel fumes. You're going to see movement of the bus, the change in size as it crosses your retina and then goes off into the distance, and you're going to hear the noise of the bus. The movement is processed in a very specific area of the brain. We know where the movement area of the brain is. The color of the bus is processed in a very specific area of the brain. We know where that is, which is not the same as the movement area. The form or shape of the bus is processed in yet another brain area, which is not, it's again a third independent brain area. The sound of the bus is processed in a completely different brain area, in the auditory cortex on the side of the head. The rest is mostly in the back of the head. And yet, every single time, the movement, the color, and the shape of the bus all are perfectly synced. I mean, never do you see a big blue blob go by followed by a colorless bus. It's like, oh wait, the bus and the shape and the color haven't quite got synced yet. And it would seem almost impossible, but
we don't think things think in that way at all.
Right.
They don't think of me in pieces of information.
Yeah,
right?
but they are, right? They're processed in completely different areas of the brain. We have different rates of neural conduction going across the brain. Are these areas talking to each other? Where does it all come together at? And so Crick called that the binding problem, and he set out to solve, in essence, the binding problem. And again, this is so simplistic to what their work actually is, but in essence, it's at some level of synchronous oscillations and activity of the brain. And when we get that synchronous processing That is the neural correlate of consciousness. One of the most intriguing and gaining in popularity right now is Tononi out of Madison has an information integration theory of consciousness, that any relatively complex system that integrates information is conscious to whatever extent or to whatever level of complexity that it does integrate information. So there's a thermostat on the wall over here. It has a mechanism, oftentimes just a bimetal coil, that the metal on the top expands and contracts at a different temperature than the metal on the bottom, and so it curls up or it loosens up. The coil gets tighter or looser. It's attached to a mercury bulb at the end, and if the mercury goes to the end of the bulb, it's a conductor and it closes a switch and the furnace comes on. So it's taking in information. It's processing different temperatures. Because of the bimetal in the coil, it responds to those different temperatures. So it's, at a thermostat level of consciousness. Again, nothing like thermostat angst, thinking it's too hot or too cold, or this is really boring. All I do is coil and uncoil all day long and, click on and off a switch. But that, and so we're, of course, at the human level, an exceedingly complex level of information integration.
So basically,
we are.
Is it suggesting like consciousness is like a continuous scale?
Yeah,
you don't have a
that's
0, 1.
That's becoming the. I think if anything is agreed upon, thinking of consciousness sort of on a continuous scale, or I like that. I think of it as a continuum rather than levels, which implies there's steps to it, but more on that sort of a continuum or a continuous scale of consciousness, and that is related to, maybe even born from this notion of a theory that's called panpsychism. Are you familiar with that?
Yeah, philosophy, right?
Yeah, everybody everything
has
has some mental to it, no matter how minuscule. So now my rock is a rock level of mental.
Almost zero.
Almost zero, but not zero. Exactly.
At least it's better than a piece of dust.
That's exactly right. And in the information integration theory, they measure it as phi.
Yeah.
So a phi of 0 is nothing. So it's not zero, then it has whatever, minuscule levels of mental is how it is in panpsychism, but mind and consciousness aren't the same thing either. To me anyway, but so yeah, the mental. So again, in a simplistic form, you can imagine easily then neurons are complex information processing units, and we have billions of them in the human brain, even more billions in the entire human nervous system. And so when you combine billions of tiny little mental / conscious activity in individual neurons, that it gives rise to full-fledged consciousness. Now that's easy to say, but the roadblock since the inception of panpsychism has always been just that combination. It's called the combination problem. It's like, well, just any pile of neurons then has that high level of consciousness. So it's, how do the neurons combine to produce what we think of as subjectivity, first-person experience, give us our consciousness? How does it make it so there's something that it's like to be? I ask my students this, actually. I torture anybody who will listen to me talk about consciousness with questions like this. This, to me, I think gets at the heart of the combination problem. So you can accept that every single neuron has a neuronal level of mental or a neuronal level of consciousness. But if I disassembled your brain or you cell by cell and kept every single cell alive, is there any consciousness? Are you still there? So that's how I ask it. I'll ask you. If I disassembled you cell by cell and kept every single one of your cells alive, are you alive or dead?
Do I still keep all the connections?
No.
Then I think I'm dead.
Yeah, right. But all your cells are alive, right?
Yeah.
Are you conscious?
Definitely not. Definitely. I think definitely not.
Right. Most people would answer definitely not. So it can't just be a pile of cells. There has to be something about the organizational structure and the communication within that system. And so I think to some extent we don't necessarily study the brain to give us a clue of consciousness any more than we would need to study necessarily any complex system with appropriate connections between the appropriate parts that are doing different things. And you know, I can have a perfectly conscious person here. I've taken the top of their scalp off. It doesn't matter what I do in terms of trying to examine their brain. I'm never going to see the consciousness that's very evident to the person whose brain I'm staring at, right? But I'm not going to see it no matter what I do by looking at the brain.
That makes sense, because a lot of computer scientists are trying to do is they're trying to image the brain and predict your behavior.
Yeah.
And for behavior, that kind of makes sense because input output, right?
Yeah.
But actually, you still cannot explain the hard problem.
No. Right.
That's interesting. So let's go back to integrated information theory, right? So it seems like it's like an extension of panpsychic.
It is. I think so. Yeah. And
Because
I think a lot of people would admit that it is. It is in essence based on
so it's
the
all
premise
about
of
like
panpsychism.
summing a lot of consciousness together, adding some complexity of the connection, and eventually you have a higher level of manifestation of consciousness.
Yeah.
But for that thing, I have difficulty with is how does that thing explain subject experiences? Or it's just like when you're complicated enough, you just suddenly feel.
Yeah, that right.
Seems like artificial to me. It's just like, yeah, at some time you just feel it.
Well, at some point, you know, magic comes into play.
Then the next question is, okay, how many are enough?
Right.
5 million connections, 5 billion connections? You need to actually give me a number. And also, it's hard for me to think about, okay, if I just take people's brain, you cut half of it, they can still survive. You have the whole package of characters and everything.
Uh-huh.
So up to which point you keep dividing, keeping smaller volume, and so finally the complexity is not enough.
And not enough to
make sure this thing happen. Yeah, because as a mathematician, that theory sounds really attractive to me.
Yeah.
It's a network problem. It's a graph problem.
And I'm not well versed enough in the information integration theory to probably answer that specific question about it. But I know that they work on hypothetical systems, and there are mathematical formulas that allow them to predict. They will actually calculate phi of a system
the complexity
to give you an indication of how conscious it might be.
Feels like an IQ test for me.
Yeah.
I'm really scared, like if you say, hey, phi is 4.5, and suddenly I did the test, I found myself is 4.3. It's okay, all my experience is worth nothing.
Nothing. Yeah.
I'm just a pile of rock putting together.
Yeah.
That would be really cool for me to think about it, like, okay.
Nothing that there's like to be me.
Interesting, yeah. A lot of people think of, so is it fair for me to say if you studied every single particles in your brain, but you don't study it at a micro level to see the forms and structures,
Yeah.
you're getting no closer to what's going on.
And I go back and forth on this so much. I mean, especially when I'm in the middle of teaching this class, I adhere to a different theory almost every day. And then I, change my mind and I think farther. And I remember specifically the first time, I've always had an intense interest in this. in consciousness in general, and specifically the question of what is it like to be. And I remember as a very young kid, before I was probably even going to kindergarten, I was fascinated by watching ants, colony of ants, work. And they clearly seem to be in the middle of some task, and they're walking across the sidewalk, and there's a crack in the sidewalk, but they're going down and they're grabbing eggs or moving eggs or building a new nest, something. They're carrying stuff back and forth, and not only amazed at the fact that ant just lifted up without, it's got a little bitty hair for an arm and is carrying around a thing that appears to be twice its size and weight without seeming to have any effort whatsoever. But then, like, going down into the crack in the sidewalk and crawling back out the other side, and it's like, God, that'd be like me traversing the Grand Canyon in comparison. And then wondering, it's like, what is it like to be an ant? And I hit across the two problems. We go back to what is it like to be a bat. So we can think, what is it like to be an ant? What is it like to be a bat? And I remember even very young thinking, well, it would be really cool if somehow you could put I probably wasn't thinking consciousness then, but my consciousness in an ant, so I can see what it's like to be an ant. But then the more I thought about it, it's like, well, that wouldn't tell me what it's like for the ant. That would tell me what it would be like to have my consciousness in an ant body. Okay, so that's not quite going to get me to where I want to go. And then realizing that, I could act like an ant, but that's not going to tell me what it's like for the ant. And then I realized there's absolutely nothing I can ever do to know what it's like for an ant to be an ant. I'll never know what it's like to be a bat, for a bat. You could even give me sonar capabilities. I'm still not. I can hang upside down from the ceiling in a dark cave and, give me wings to fly around and use my sonar. It's still going to be Bart with a altered body and ability to fly and living on mosquitoes that I fly around and catch at night. And so for a bat, what is their experience like? I'll never know.
So is it fair for me to say you think consciousness is tied to embodiment? Depending on the sensor you got, you probably will develop different type of consciousness. Let's say if you it's evil, but put a baby's brain, take it out of, you don't have the baby hands, you don't have all the speed and everything, but just say I basically put you into a bat.
Yeah.
Now you have the no fingers, but you have wings and everything exactly in the settings of a bat. Now, finally, you can probably start to feel like a bat.
Get closer, yeah.
But then we're also assuming there's no pre-wired stuff when the baby were born, which is human, right?
Yeah.
So whichever way you think about it, you probably need to put a bat brain into the bat. If you put a human there, you still have some have to take over with you. Just when you go have embodiment with a bat.
Yeah, that's probably as close as we could get, but it still wouldn't. I wouldn't know. But that baby's brain might have some clue.
But then the baby won't be able to communicate with us.
Exactly.
So that's actually a
And even when you can, I could sit here and say, what's life like for you? What is it like to be Song? And you can tell me, but I really don't know.
You can try your best.
What is it like to be Song for you?
Yeah.
And even with all of these theories, you mentioned the hard problem earlier. And, I find it quite attractive to think about the binding problem, and that's really cool when we have gamma oscillations in these areas of the brain that correlates to conscious experience. But it still doesn't answer the question, but why should gamma oscillations give rise to something that it's like to be? Why should they give rise to experience at all? we call, it's the qualitative state of an experience, or qualia. Um, and the smell of coffee brewing in the morning, I have a visceral response. It's like, oh God, it's like heaven. It's really kind of indescribable about the experience of smelling coffee, or smelling a rose, or looking at the blue sky, or why do people sit and watch sunsets? Why do we describe them as so beautiful? Why does it seem awe? Why do we get awestruck at something like that? Why do our experiences have any feel to them at all? And that is directly related to what consciousness is. It's the feel of an experience, rather than just it's a sunset, that's coffee, boom.
I can purely recognize coffee.
Right.
I can purely recognize all the molecular substance of the coffee, but still you don't feel.
Right. So the hard problem in its modern form is the problem of explaining subjective experience from physical goings on in the brain. There's this gap, and it's not as if the hard problem is new. David Chalmers invented that terminology in 1994 at the first ever Tour de Science of Consciousness conference in Tucson, and he wasn't trying to dominate. He had no intention or thought or vision that he would dominate the field of consciousness studies for the next 30 years by that simple question he posed in his presentation, his paper talk. But he broke them down into what he called the easy problems of consciousness, discriminating stimuli, problem-solving, decision-making, things like that. A lot of what psychology does. Not by any means easy, but we have a pretty good idea of what we're doing and what questions to ask, and a methodology to get answers to the questions. So we're solving some of those problems. They seem solvable. And he pitted that against what he called the hard problem of consciousness. It's explaining how or why physical activity in the brain gives rise or leads to consciousness or subjectivity, or in essence, why do our experiences have a feel to them at all? It would seem like we don't really need that to survive in the world around us. And back to, I've always had a lifelong interest in consciousness, and as a scientist and somebody interested in the brain, and that's what I taught in my area of psychology. And, I would start, I just found myself reducing and reducing and reducing farther. It's like, well, let's go down to let's start with the brain. Well, let's go to hemispheres. Well, let's go to lobes. Well, let's go to neurons. Well, wait, what are the neurons made of, and matter and energy, and you just keep going farther and farther down the scale, and it's like, geez, at some point we can't even tell the difference between matter and energy. Matter is energy, and that's when I kind of threw my hands up, and I associate the explanatory gap, or the hard problem, is the same gap as the gap between macro physics and quantum physics. The unifying theory of everything really is talking about these two. How do we reconcile more gross, observable level physical phenomenon and what we see in the quantum world, which is just sort of bizarre and crazy? So we can't really look at what's going on in the quantum world, doesn't predict readily what we observe in the macro physical level of analysis world, the classic physics versus quantum physics. It's like they don't seem to fit. But so I think when we have that understanding, and when we can understand quantum physics enough to be able to explain how that gives rise to macro physics or classical physics, that is the explanatory gap. I think it's the same gap. So I think our understanding of
we have string theory, at
Yeah.
least.
Yes, that's right.
We probably need a string theory for psychology and
Yeah.
consciousness, right?
Yeah.
Yeah, I was disturbed by that too. It's just, you for a smaller world, you have a set of rule, and for macro world, you have another set of rules.
Right.
And you don't give me a clear cut.
Yes.
Like, this is micro, and this is anything above is macro.
Right,
Macro
right.
is just like, go with your guts and try. They actually generally fade away. It's not
Yeah.
like it's going to fail right away when things gets bigger. It's just like, it's less accurate.
Yes. Right.
Now in the combination of these things, so it's like theory 1, working for micro, very accurate. As you increase the size, less and less accurate. Meanwhile, this one at micro start to actually get a little bit of accuracy, and then once you move there, it's got more and more accurate, and
Right.
eventually the classic one take over.
Yeah. Yeah. I see that same fit in sort of our trying to fill the explanatory gap, and that's the explanatory gap is the same between physical functioning of the brain and consciousness or conscious experience.
Interesting. So do we have which one, like in terms of psychology, but use the analogy in physics, which one is more advanced right now? The quantum micro theory in consciousness, or actually the macro classic theory? Which one is more, people use more in application to explain things or to make predictions?
Way more people are on the macro.
Okay.
Personally, I think there's more promise in the quantum avenue, the micro, because I think with every level or every neural correlate of consciousness has that problem. Fine, but why should gamma oscillations give rise? That doesn't solve the hard problem of consciousness. Okay, so and this is where we're missing the data, because there is a quantum theory, but it still doesn't answer the question of, okay, so it's superposition of proteins in the dendrite, in the dendritic spine, or in the synaptic gap, or gap junctions is another place they're looking. So it's some quantum event going on there. It still leaves me with okay, but why does quantum superposition of proteins give me that being moment of consciousness?
So
why does that experience feel like anything at all?
So you want more than associations.
Yeah.
You want explanation. But may I ask on that theory, are people saying like when that thing is in superposition status, that's when you have consciousness? Or actually when you observe, the whole thing collapse?
I don't want to put words in the theory's mouth. I think it's related to collapsing the waveform. When it collapses,
so it's actually when everything collapses, you start to make a decision. Because before that, I kind of feel like I have free will.
Yeah, right.
And then the moment you observe, you make a decision, and everything just collapses. Is that more like the right way to interpret it?
Probably because I don't know enough about it. That seems to make sense with that. The theory of Hameroff and Penrose. I'm not sure they would answer the same way, but my level of understanding, or my ability to understand it at a very deep level is somewhat limited, because I'm not a quantum physicist. I learned most of what I know of it from Googling
that's so
and reading articles.
Yeah. If we go back and go to the study of consciousness during the history, it's really interesting. Every time we have a scientific breakthrough, we would kind of associate that into brain. It's like, the brain is like a steam machine.
Yeah, right.
And now brain is like electricity, and now we think, okay, brain is like computers, and brain is like quantum mechanics. Maybe later we will say brain is like string theory, or string or something like that.
Well, that's part of I think, inherent in the difficulty of it, is that we talked about the information integration theory and the complexity. We can't even begin to fathom how complex it is. We don't have that ability to even imagine how complex it really is. When you have 100 billion neurons in the human cortex, each one of them synapsing perhaps 10,000 other connections with other neurons. I had a student who actually calculated this at one point, but it's like 5 trillion connections in the brain. Well, first of all, none of us even have a concept of what a million of anything is. That's inconceivable to think of a million of anything. I would, in a room about this size, I would ask my students, I always have a travel mug of coffee. It's like, how many of these would you estimate I can fit in this room? And it would range from 100,000 to 100 million. So I just use that as an example of that's how clueless we are of really conceptualizing what a large number is. Of 500 trillion or 5 trillion connections, weighted differently in different patterns. It's like, it's so complex that to think we could even study it and then say, consciousness makes perfect sense, mean we would have really any idea. We're still so just barely scratching the surface and understanding the brain. We've done a pretty good job at the sort of cellular level, which is have been our intense focus. So we take neurons out, and we play with neurons, and we can find patterns of firing and what makes them fire and what chemicals they release, and this must be how they communicate. But we then sort of jumped from that to this sort of mistake of identifying disparate areas or different areas of the brain. That here's the auditory cortex, here's the occipital lobe, the visual cortex, and here's the association cortex, and here's what allows memories to be formed, and blah blah blah. Almost when you look at a picture of the brain and it's colored differently by these different areas, it looks like they're separate structures, but they're all massively interconnected. And even chemically, you can't create an imbalance in one chemical system without creating imbalances in all the others, because they're all. So if I change dopamine levels, I'm also going to change serotonin levels. I'm going to change acetylcholine levels. We're getting better, and partly due to technology, where now there's been a shift in focus to pathways interconnecting, communication between brain areas. So it might not be this area of the brain that I've got a purple circle around is sort of independently responsible for auditory perception. It is, it may be the input from other areas or the output going to other areas. It's all so much more hyper complex, but
so
with
it's a distributed system.
Yeah, okay. Exactly. And now we're starting to, we can at least see them, which gives rise to say, now we should study them more. We have tensor diffusion imaging and technology like that allows us to at least start to look at those pathways. But there's a saying I really like. If the brain were simple enough for us to ever understand it, we would be too simple to ever understand
it's depressing,
it.
Right?
Yeah, but
Music, love,
to
all
some
stuff.
extent, there's a lot of truth to that. I don't internalize that enough to just throw my hands up and give up and say, screw studying the brain. Too interesting to do that. So you sort of carry on as if you have some glimmer of hope that will lead to a greater understanding, and we will. But man, we have a long ways to go. And sometimes I do question whether we have the capacity to even understand, given the immense level of complexity. And nothing even compares in terms of being the most complex structure in the known universe.
Interesting, because people are debating about, are we living in a simulation?
Yeah.
And then people say, well, you cannot literally test that because you are in the simulation.
Right.
But now if you go back to your brain, it's just the same thing. Can you think about your brain? Well, technically you are thinking about the thing you are using to thinking about this problem.
Right.
So probably it's just impossible.
Well, there are scientists at MIT that are actually trying to answer that question. Are we living in a simulation? They created a simulated universe, and then they're letting the universe sort of evolve on its own. And their argument is, if it evolves the same way that what we think we're in now evolves, then almost certainly what we're in is currently a simulation.
Or at least the probability we are living in a simulation is greatly boosted
Yes.
from zero, right?
Right. Yep.
But that will go back to another question that is, okay, so the way to prove or test if we're living in a simulation is try to create a similar simulation and see if nothing is possible.
Yeah.
And then let's answer after that, is ours one? Same thing with consciousness. How to build, how does consciousness work? Maybe we can actually take the detour, just say, let's build one.
There's an interesting project. It's called the Blue Brain Project, and I find this fascinating. And most people I talk about don't find it nearly as fascinating. But because of what I just argued, that the structure and connections of the brain is so complex that we barely are scratching the surface and really understanding just how complex it is. So if we say, well, let's try to build a system with circuits and electrodes and silicone, we could not build a mechanical, physical, electrical simulation of the brain. So this group of scientists thought, well, we're going to build it with biological data. So they would just input into the simulated brain system. Not again, they don't have a fake brain on that they're throwing things into. It's all computerized, but so simulated. And they just kept adding and adding and adding biological data and let the brain sort of build itself based on all of the data. And they got to a point, crazy as this sounds, that as they're monitoring the simulated system, it began to show gamma oscillations, which kind of freaked me out, because one of the neural correlates of consciousness is gamma oscillations. And it's like, well, holy crap, is this thing conscious now? And the scientists said, no, we don't at all think it means that this thing is conscious. But I obviously never had a chance to ask him, but I'm like, well, why not? If we use that as a marker of consciousness in humans, then why would you not attribute it to a machine? And because I don't personally believe that there's anything in biology that necessarily entails consciousness, I don't think organic matter is necessary for consciousness. So I think it's possible. That I think is a unique approach, and a potentially fruitful approach is to just enter the data and let it build itself, because we can't replicate it in terms of all of the interconnections that are there now.
Do you believe we can upload our consciousness to computers?
Yep, they're actually doing it. They're working on it moving
Do you
quickly.
believe it?
Well, what year was that? Probably 5 years ago. The scientists working on it predicted that they would be able to do mind uploading within 20 years.
Yeah.
So now, yeah, I mean they can look at, they're looking at connection and connection strength, and
for me, it sounds like a straightforward thing to do. We just like take neuron by neuron, copy one by one, put them into computer.
That's kind of what they're doing.
Right?
Yep.
And then when people start actually doing it, you realize how much work that is.
Yeah.
Just for one brain.
Yep. And I actually looked a year or so ago just to try and update myself on, well, where are they in this? And it didn't seem, I couldn't find where there had been like a lot of breakthroughs or a lot of progress. What I really need to do is go back and I can find all those conference talks and listen to that talk again, because it was fascinating. But the presenter and his colleagues certainly thought that there wasn't a question of is it possible. The question is when it's going to happen, which again you obviously wouldn't do that work if you believed you had to have a brain to have consciousness, or you believed you had to have a biological substrate to support consciousness. Now, what can't happen is that you would never be able to download that into another human brain. By that point, we would have to have advanced enough robotics that it would be 100% not a cyborg, it would be a robot with an entirely electronic brain, maybe plasma brain by then, who knows.
So we just live in avatar.
Yeah.
All the time.
Yeah.
We don't need this fragile body
Yeah,
to feel anything.
we don't. Yeah.
Now, if we start to build machine intelligence, let's say that's a hot topic right now, right?
Mm-hmm.
And people are starting to worry about, okay, we're going to have Skynets,
Yeah.
and the machine is going to have desires, wills,
Yeah.
as they become smarter and smarter and smarter. So the first question I have for you on that is smart intelligence equivalent or more or less consciousness? Can I be smart, capable, meanwhile don't feel a thing?
Oh yeah, certainly. I mean,
So they're confusing these two concepts.
I think
right?
so. Yeah.
Okay, so based on that, do you think it's possible to build a machine intelligence which is not based on the model of the brain, because we clearly still don't know how the brain works?
I do. Yeah.
So they may have a different type of consciousness. Maybe they feel things
Absolutely.
a different way, but they do
Yeah.
feel. Do you think it's possible?
Do they feel? I'm not sure.
Not the way we feel, but they will
Right.
feel.
Oh, that's a really good question.
Because I kind of feel like if they want to feel the way we feel, they need to have the same relationship with us as us,
Right.
and body, and temperature, and all the feelings, right? It's gonna be hard, like love and those kind of concepts. But maybe they
Right.
just don't need those kind of concepts. They're not human either way.
Yeah, that's true. I think they might behave in ways that we would attribute feeling, but that might be in our inherent desire to always look for a motivation of
So protection.
try and explain why would that robot have done that? Why did that machine do that? Most of the time when we try and answer that question, you attribute some want, need, or desire, which we think of as an internal feeling, but not necessarily. If we can separate biological need or biological drive from wants and desires, which doesn't seem like it's too difficult to do, it wouldn't have a biological need, but the need of a machine to sustain operation and functionality might drive it to behave in certain ways that would, of course now we're giving it instincts, so might as well give it feelings, right?
Yeah, it's the same thing with puppies, right?
Yeah.
We project our feelings on puppies. We think the puppy does this because
Right,
the reason we give them, but actually maybe they just did that thing for some puppy reason.
right. For a reason we have no idea.
So it's really hard to tell. Actually, when you mentioned that thing, when the thing started to have like a gamma oscillation, that was actually the hardest part of the hard question is you don't even know how to test.
No.
Even nothing has one, you don't know how to test.
No.
Even nothing says it has one. It expresses feelings. Please don't shut me down. Still, it can be fake.
Yeah.
So what will you think will be a acceptable test for you? It's just like if the machine does this, okay, I'm going to treat you equal from
Well, yeah, we could,
will admit you have
to
rights
some
and everything.
extent, go back to the Turing test.
Which is purely behavioral, by the way.
Yeah, but it's still going to be. It will. I mean, you certainly can't just ask. Are you conscious? What
Even
would
though I
it?
can easily program a computer to say yes.
Yeah, right.
Only for that question, though.
What's going on inside? How would you? I don't know. I'm gonna fall back on what I think is the most promising lead right now, and that is developing the way to test phi through something like the information integration approach, where we can get some estimation at least of phi, and it's quantifiable, it's mathematical, and start there. So if it has hi-fi, then it is likely has some level of consciousness. And I don't know that a machine would ever have emotional experiences the way we do. But would it have sort of free thought during idle time where it just ponders the meaning of it all? I don't even know that. But in that world, I mean, right now, a lot of people you have this conversation with, and especially on machine consciousness, is, well, whatever they think is just programmed in, so it's not their thought. And what causes most concern amongst people right now isn't that I can build a robot that would follow one of my commands or even be able to utter something intelligible back that I could understand what it's saying, or even build a response. It's that we create artificial intelligence. We'll just call that AI. The next step is AI plus, and that's an artificial intelligence that's more intelligent than us. Then, because we're not intelligent enough to create it, AI plus creates AI plus plus, which is like super more intelligent than us, to the point where AI plus plus would kind of say, well, we don't need humans anymore at all. That's the singularity, right? Exactly. So it's that, I think, is the fear, and it's interesting to read.
I'm okay with that fear. Yeah, I listen to so many people talking about it, and I like one of the opinions that is, yeah, we live in the world. A lot of things are stupid, more stupid than us, like an ant, like a dog. We don't feel the necessity to kill them all.
Right. Yeah.
As long as they don't stand in our way, right?
Yeah.
Yeah. There was one time I was listening to a podcast, and the host was always interested in those kind of questions, like, do you worry about existential threat? When they get smarter. And the guest was super interesting. He said, like, you guys are smart, so you have never seen anybody smarter than you guys before. But we see people smarter than us all the time. I have no problem with that. Why should I have a problem as a machine is smarter than me? I said, well, that's actually at a certain level true. So I personally actually don't worry about that. But since we're talking about this, it's hard to tell if a machine is tricking you or really have consciousness.
See, I've been trying to figure out whether you're just tricking me or whether you really have consciousness.
That's my question here. It's just like, how do we know human has that? Then we came to a point that is, do you think understanding, compassion is, I won't say possible, is it an illusion?
No, I don't.
The resonance between.
And the reason I say don't, I'm going to say I don't think it's an illusion, is that, and there's a growing effort with a lot of research now on animal empathy, which is really, really cool. And I think if you behave in a way that shows empathy, you could pretty much say that's compassion, to some extent. One of the coolest ones that I read about was they had two rats that they raised together, and cage mates generally become close. They become chums. They're pals. And then they separated them, and I don't know if they trained both of them. They at least trained one of them on how to open the cage from the outside. And then they have the two pals that were raised together in separate cages, and they make them both hungry. And then they let one of the rats out and gave it a pile of food. And rather than this hungry rat who's been food deprived, rather than just going over and wolfing down all the food, the first thing it did is went and let its pal out of its cage. So it had less to eat, but it was, a pretty good demonstration of animal empathy, you might say, animal compassion. So I don't think that that's an illusion, any more than consciousness is an illusion, and I used to claim that, probably because thinking about it made my head hurt, and it was the easy way to give up, to say,
Just become cynical.
Well, it's a struggle for somebody who's trained in, Western scientific methodology, which, when you're doing science, you adhere to some level of determinism, and from a deterministic perspective, it's very difficult to not. You either have to claim consciousness doesn't really do anything, and if you claim that, you're almost saying consciousness is an illusion. But from that sort of determinist materialist perspective, you would have to always argue that consciousness is the physical functioning of the brain. And if you get to any point where you think the brain, physical functioning of the brain creates consciousness, creates mental, which is not physical, it's like, well, if consciousness is not physical, then it can't have a causal effect on the physical functioning of the brain, so consciousness can't play a causal role in changing my behavior. And then any other way to look at it, you sort of get mired in this weird convolution of dualism. And especially through the 80s, every psychologist who tried to talk about consciousness had a dualistic theory of consciousness, which at that time, you can't have a true scientific theory of consciousness and have a dualistic theory of consciousness at the same time. That's a spiritual explanation for a physical phenomenon, and that's not allowed in science.
Different world.
Right.
They need to be studied in two different ways.
Exactly. But now, it's actually uncomfortable for people in the world of consciousness studies right now, because even the panpsychism approach, the information integration theory, there's a dualistic flavor to them. David Chalmers, who the hard problem, started all of this explosion of research and interest. To many, even to admit, is there a hard problem or not? Is the hard problem real? Is, in essence, to lean towards dualism. And his is kind of a dual aspect view of it, where he argues in his book that we have experience part of an event, and we have the sort of physical part of the event. And what we really ought to be doing is we need to find the relationships and be able to define precisely the relationship between those, which kind of says the experiential part of any given event is something separate from sort of the physical part of the event, which kind of has a dualistic flavor to it as well.
Let's say this: if you separate the behaviors from the consciousness, right? When you are not moving, let's say you cannot even move, but your brain is clearly conscious, you can simulate a lot of things in your brain.
Yeah.
So that seems like already answered that question. Is they can be separate.
Yeah. Oh, definitely. Yeah, the underlying physical, and at least I still tend to think that, there was physical, chemical, electrical activity going on in the brain.
Material side of it.
Right. So I don't remember what the specific question was that led that train of
just chatting
discussion.
Yeah, okay. Yeah, so we build machine intelligence, and I think you think it's possible to build any consciousness outside machine, right? So
Yeah. Well, this is. Can I? I'll give you a little example, because I when I ask my students, without any background, whether they think a machine can be conscious, almost all of them say no.
Really?
Yep. No, they're just created by us. They're just programmed to respond in certain ways, blah, 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 blah. So I call them machinist.
Okay.
So I say, well, imagine that I wake up one morning, it's like, well, darn it, I'm blind. I go into the doctor, and they figure out that I've had some internal damage to my occipital lobe, visual cortex. But they rush me right into surgery because they're just going to plant an electrode patch to form the connections that were connected there via the neural tissue in the visual cortex. And I get out of surgery, and it's like, hey, well, did it work? Can you see? It's like, oh, God, yeah, I see just fine. It's like nothing ever changed. Perfect. Thanks, Doc. Next morning, I get up, oh, darn, I can't hear anything. Back to the doctor, oh, same thing, you know. And they put an electrode patch in, and, you know, just day after day, this goes on. Now I'm totally numb. I have no bodily proprioception. I can't plan. I can't think. I can't talk. I can't move, blah, blah, blah. And, you know, this goes on enough, and every single time it's like, oh, yeah, I can move perfectly. Everything seemed just like it was. I mean, you could imagine this going on until I have an entirely electronic machine brain. And I've claimed every single time that, no, I see just like I did before, nothing about my experience seems different. No, I hear just like it before, nothing about my experience seems different. I feel, I have emotions, I speak, I can move, everything tastes the same, blah, blah, blah. Would you claim now, because I have a machine brain, that I am not conscious? And then probably not. You know, so maybe machines can be conscious, and that seems like a perfectly feasible chain of events. We could do a lot of that now. We have done a lot of that now, implanting electrode patches on people's brains.
Have you been following Neuralink?
Yeah.
It's crazy what
Yeah.
you're trying to do.
Yeah. You know, we can do that with electrode patch now, and now I can think about grabbing a cup, and I'm actually, when I think about grabbing a cup, the robot arm goes out and grabs a cup.
Even the EEG readings and everything.
Yeah. Yep.
That's the first time I saw that thing shocks me.
Yeah.
Like, you can really send signals by just thinking, and they
Yeah.
capture the wave, or fMRI, which is slower, but
Yeah.
they can somehow project. But again, that's at the behavioral level. But even for that, it's already very, very impressive.
Yeah. The day and age of, cyborg is becoming closer to reality. I just taught a course a couple of years ago. It was a senior seminar, and that was the whole topic of the course. I called it science fact or science fiction. How the science fiction world is becoming science fact, like cyborgs and robots and things like that.
What do you think the future? We're hitting the 1 hour and a half already. Quickly.
Okay.
One last question. We can chat next time. What do you think the future will be? Human and robots, or cyborg? Who's going to take over?
I think we'll skip the cyborg phase. We will go cyborg phase for therapeutic purposes.
Okay.
So this person's brain is still fully alive and fully functioning, but they're quadriplegic. Would we have the ability to take their brain and place it into a robot body, and they would learn to command the robot body and maintain their consciousness that they have now? So I think that will go. I don't think we'll intentionally try and invent cyborgs.
Just piece by piece.
Yeah,
They'll replace.
that will lead to more sort of conscious robots.
Okay. Quick guess. No scientific evidence. When will that happen?
I don't think it's going to happen by next Tuesday. Well, I don't think it'd be crazy to say in 100 years.
100 years. Okay.
I don't know if it'll be that long. You know, with advances in robotics and the way that's going, and you know, if they do get the mind uploading thing done within
20 years.
Within 20 years, and we have robotics advanced enough in 50, they're going to say, well, heck, let's try and download that mind into this
After that,
robot.
we will all live forever.
Yeah,
Great.
right.
Okay, thank you so much for the talk today. It
You
was
bet.
super interesting.